The question is not true regarding decalcification of bone specimen. See, when you actually take bone, these basically bone specimens are used either for histopathology or they are used for grafts. So, in a lot of cases, what you do is you take bone, you crush the bone, and you place it directly into the defect that you need. That is one form of using the bone. However, the bone that you use to replace the defect is not going to fill the defect, it just acts as a scaffold. So, this bone eventually gets resolved, and in place of this bone, you have new bone that is getting formed. Okay, so when you use the bone, one of the advantages of bone is as such, the bone tissue as such is like freeze dried bone or decalcified freeze dried bone, DFDBA as we call it. One of the main important properties of DFDBA is the fact that it is osteogenic in nature. So that means to say that this decalcified bone has the ability to form new bone. Like I told you, it acts as a scaffold, so it gets absorbed and new bone is formed in this place. So what does it do? It do is that it stimulates the osteoblasts that are close in the neighborhood of the normal bone. This bone graft, the DFDBA that we place, it stimulates those osteoblasts to lay down bone and at the same time osteoclasts to resorb the decalcified bone. So that is primarily what is the function of the DFDBA. So from that we can identify that it has increased osteogenic potential. So this is the right answer. Second is, see, since we are decalcifying the bone, that means the entire inorganic content is removed and only the organic content is left. And as we know, organic content of the entire tooth structure or bone is nothing but collagen. So it exposes the collagen matrix. Now coming to these two options, what happens is, there are three main agents which are used for decalcifying. One is 3% hydrochloric acid, second is 5% nitric acid or HNO3, and the third one is 5% formic acid. So these three are the three most commonly used agents. Amongst this, 3% HCl is the most commonly used because it is easier to, the availability of 3% HCl, one is easy, and second thing is it is much more affordable as compared to the other two agents. And that is why you use 3% HCl, and that is why answer 1 is also the right option. So this leads us to point 2, which is the wrong answer. So this is the false statement. Why? Because see, in order to stimulate osteoblasts, you need to have bone morphogenic proteins. See, bone morphogenics or proteins, or BMP as we call them. These BMPs are basically used to improve the morphology of the bone. So in the process, what happens is we are trying to induce a morphology for the bone. As a result, you need the morphology of the bone in order to stimulate the osteoblasts, and that is the reason why bone morphogenic proteins are used. And once you decalcify the specimen, the bone morphogenic proteins are exposed on this decalcified specimen, and that is why this DFBBA is osteogenic, because it has this BMPs, and these BMPs help in uh, bone formation. So the answer over here, which is the wrong answer, is that it leads to loss of bone morphogenic, whereas it actually causes increase in BMPs.